What's up, everybody? Today we have special guest on our show, someone who has significantly changed the way many of us think about software design and architecture. Mr. Mark Seemann, who has brilliant books about software design, about dependency injection. He has really cool courses on Pluralsight, clean coders, and he's known for his deep insights into functional programming, solid principles, and dependency injection. He is the author of Dependency Injection in .NET, Dependency Injection Principles, Practices, Patterns, and the code that fit in your head. And below we'll share the links related to his courses on Pluralsight and clean coders. Thank you very much, Mr. Seemann, for accepting our invitation. Today we have a lot of interesting questions from me, from our audience, about dependency injection, about functional programming, and overall about software development. So if you don't mind, we can start. Yeah,
that's fine. And by the way, you're welcome to just call me Mark if that's easier for you. I do realize that some okay, so good. Some cultures really do want to stand on formalities and do whatever makes you more comfortable. But usually people just call me Mark. That's what they do here in Denmark. So that's what I'm used to.
Thank you, Mark.
Sure.
So my first question is about software architecture. So we have sections related to software architecture, functional programming questions. So first question is about, what do you believe are the foundational principles of a well-designed software architecture? What is your honest thoughts about it?
Yeah, so I think the first thing that's important to realize is that there's a lot of different kinds of software architecture or IT architecture in general. So that's one of the first things that I learned from a colleague of mine many years ago. It's not the first thing I learned, but when I started in a new job, I had this colleague for maybe half a year before he moved on, and he taught me that when people are talking about architecture, you have to first figure out what kind of architecture do they have in mind, because there's a lot of different things. And he had a complete, matrix, like a 3x3 matrix. And I don't remember, all the different combinations, what they were, but he had it all figured out. I could just draw that on a whiteboard somewhere. But basically, the kind of architecture that I have been mostly interested in is what you could call small scale architecture, or, architecture on the code level. So, I'm very interested in figuring out how do you organize code bases in such a way that they can evolve and they can stay up to date, and you can sustain that code base, or you can use that code base to sustain your business or your organization for many years, long-term survivability of the code base, if you will. That's what interests me. But there are other kinds of architectures that, that other people have in mind, like, there's IT architecture, which machines do you actually deploy? Where do you deploy them? How do you set up the network and so on? That's maybe not software architecture, but IT architecture, still relevant though. And you have people running around being enterprise architects. And, the word enterprise architect, for example, is quite a word that most people don't like. But I've definitely been in organizations where I think that such a role is very important, because you need someone who has the technical expertise to walk around and talk to all the different sub-organizations in a bigger organization in order to have some sort of idea about what's going on. Oh, team A over there is doing one thing, team B over here is doing another thing. And I don't see an enterprise architect's role to be, to come in and decide or to dictate what they need to do. But I think it's very important to have a person walking around in such an organization and saying, oh, that's interesting. That team over there is doing something, and this team over there is doing something. Maybe you guys should talk to each other, because it seems like you might actually benefit from, doing, you have something in common, and maybe you should talk to each other. And having a person walking around and doing stuff like that, I think, is also very important. So that's not me, by the way, but it's just to outline the landscape here and see there's a lot of different ways you can think about software architecture. And all the answers that I'm going to give you today is just from my very, very small, narrow perspective of, how do you organize a code base so that you can keep on working with that code base for hopefully many years from now on. So that's a very long preamble. Your question was, what do I think are some of the fundamentals? Was that right? Yeah. Of what. So the first things that I look after is I want to understand what the motivation is for actually creating this software that I'm being asked to do some architecture for. So the first couple of days at least are not technical at all. It's just trying to figure out, okay, what are the driving forces here? And some of it is business oriented in the sense you want to understand, what is it that the business people or the non-technical people, what is it that they want? You often have some sort of sponsor, someone who's not particularly technical, but who actually approves the budget. And you need to understand what that person is trying to get out of that thing. But on the other hand, he or she is not the only person with all the knowledge, because he or she may lack a lot of technical knowledge, and then you need to go and try to find some other stakeholders in that organizations to figure out, so we have this person who thinks the person with the money also always thinks that they can get much more than they can get for much less than it actually costs. So now you need to figure out also, what are the other forces that are working? What do we, what kind of hardware do we have to operate on? Which kind of personnel do we have? If we probably have some programmers already. Which programming languages are they comfortable with? Do they want to continue working in the same programming language? Do they want to switch to another programming language? That might be. Do we need to go out and hire new programmers, or do we work with the ones that we already have? And all of these things you need to figure out. And also, what's the time frame involved here? How soon are we expected to be done? And then once we are done, or once we've delivered the first minimal viable product, then for how long do we expect the software to last afterwards? Because if you can imagine that you're creating, I've never done this, but you can imagine, just for a simple, easy to understand example, imagine that you're building the FIFA World Cup 2024. Well, it's over already, but then 2028 or something for a big sports event, and it's basically a one-off event. These things come back, but still you're probably doing a lot of custom software for that particular sports event. And then you might ask yourself, okay, so do we need to be very careful of making that code base super long-term maintainable? And that might not actually be the case, because it's sort of, we go there and we're done with it, and we're probably going to do another thing in 4 years time afterwards. So maybe long-termism is not really the appropriate thing to do here. But in other cases, you might want to, design something that should last at least 10 years. So I think I was just talking over you. So
no worries. Yeah, that's completely okay. Yeah, thank you very much for answering briefly. Say we decided our architecture, everything is okay. We have the organizational structure. As far as I understand, organizational structure is also important, defining all this stuff. So how do we approach balancing between flexibility and scalability in an architecture, especially in complex systems?
Right. Yeah. So I'm not. So you said scalability and maintainability
and flexibility.
Flexibility. Yes. Okay. So no, that's okay. So in the best case, these two things don't need to be opposed. You might actually be able to arrive at a kind of architecture that can be both flexible and scalable. It really helps. So one of the things that I really maybe didn't fully answer your previous question, because I only got to talk about the organizational concerns. So from there, there's still the next step is, how do you even arrive at a technical architecture once you have gathered all of those requirements, if you will. And so someone actually asked me that also a couple of months ago, and my honest answer is, after a couple of decades of experience, you sort of just accumulate a lot of different, you could say, design patterns, if you will, but they're sort of like architectural design patterns. And then one of them seems like that's probably the best one, and then you pick that one. So that's a little bit, mystical. It's not really, for me at least, it's not really a there's no algorithm for that. It's not a methodological process. It's more like I just draw from experience. So this is probably what I also would do if giving such a requirement where someone says to me, we need to be flexible, but we also need to be scalable. So what kind of architecture do you pick from that? And I would probably start to think in terms of something like CQRS style architecture, because if you need something that is very so again, scalability can be more than one thing, but at least the CQRS architecture is maybe appropriate if you have a lot of contention. If you have a lot of different if you have a lot of riders that sort of compete for the same resource, you need some sort of way to deal with that in a scalable fashion, and CQRS is fairly good at that. So that might be one of the ways we could interpret that word scalability. But on the other hand, sometimes it maybe just means throughput, and basically maybe if you just have a ton of readers but not really a lot of writers, you could just set up a lot of cheap machines and just have things running in parallel. So that would be sort of the concerns that I would be thinking about here. But again, we probably need to dive a little bit deeper into figuring out, okay, what does scalability actually mean? But so I've just tried to outline two of those. We can get back to them if you want to. And then the flexibility part is more. I think that's more there's more a question of writing codes that is sufficiently modular that it's fairly easy to change. And there's a guy. There's a guy on the internet that goes under the synonym of TEF, so no one knows his real name. Well, he probably knows his real name. And he has something, he has an article that talks about, how the most flexible software you can write, or the most flexible code you can write, is code that is easy to delete. So, that's really sort of like the extreme part of it. And I don't say you have to write code like that, but in general, people often, when they're faced with this requirement of being flexible, I often see people try to, predict a lot of things. So they try to build in all sorts of extensibility points and say, we need to be flexible, so we should be able to change this in the future. And then they, maybe build in extensibility points or hooks or whatever you want to call it. And my experience with doing that is that you rarely can predict the changes that are coming in the future. So the easiest thing you would probably, what I try to do today is to write code that's easy to delete, because if it's easy to delete, it's also easy to change. So instead of trying to predict all sorts of things where you can go in and say, we need to follow the open close principle, we should write code that is open to extensibility but for closed for modification, we might also just say, well, yeah, but we can also just write code that we can, or maybe it's not easy to delete, but it's just easy to ignore. So we might just say, okay, so this part we have over there, I don't really want it to work like this anymore, and maybe we'll delete it, or maybe we'll just let it be there, but then we could just create some new code that sits side by side with the old thing. So that's a little bit like the strangler pattern, for example. But the point is, the more, yeah, thank you. So, but the more you can decouple things, the easier it is to sort of go in and replace old behavior with new behavior, and you can sometimes have them sit side by side and then have sort of switch over period. And then once you switched over to the new way you want to do things, you can go and delete the old one. That's the sort of things that I would have in mind, given requirements like that. Well,
So, in software design, let's say in some companies we are receiving architecture, okay, there is a guy who drew all this stuff, and as a developer we are working on internal design.
mm-hmm.
So when define this type of internal design, how much should we understand about the business to make a better design? Do software developers really need to understand business business, or it is just enough to receive user stories? Okay, I have this user story, this is my current sprint, I will do this, and that's all. What do you think about it?
Well, I think that's probably some sort of maturity, slope where I don't know which way your video is going because I think I'm
Yeah,
seeing
that's
myself in a
completely
mirror
okay.
anyway. But anyways, you can imagine that you have some sort of coordinate system, and I think if you measure, one out of one axis, maybe the maturity of the developer, and then the kind of contextual awareness a programmer needs to have. I think it should be some sort of rising line, at least in the sense that I wouldn't expect from a junior developer or someone very new in the industry to have a lot of contextual awareness, because if you just came out from university, or let's say even a boot camp, and you're basically still struggling with just getting the computer to do whatever it is that you want it to
Yeah,
do,
got it.
that's probably enough for you. And I wouldn't really expect from such a person to be able to be aware of much more than that. So
Okay.
for persons like that, I would probably find it appropriate that they've been fed, fairly compartmentalized small tasks, and asked to deal with those. But then I also think, the responsibility of senior developers or tech leads and so on is also to make sure that they don't stay in that little box, that they, as they grow as developers, they grow not only their the technical abilities, but they should also grow their awareness of what's going on around them, because there's a lot of decisions that you have to make when you're writing software where it absolutely makes sense to be aware of the broader context. And just for example, again, we're talking about this thing about sustainability of your entire organization. You might say, oh, I'm planning for this code to last only 2 weeks. You might make some completely different decisions that if you're planning for a piece of code to last for 10 years. So I think that's just a very coarse-grained example of situational awareness, but that sort of now
Mhm.
means that instead of asking someone else, you might actually be able to make that decision yourself and saying, okay, so I understand the lifetime of this project, so therefore I can go and make some decisions for myself. So that's just
Oh,
one example, but I hope that makes sense. But
yeah, exactly.
I think
Definitely.
it's very I think it's very beneficial for yourself as a programmer, but also for your organization, if you are aware of the bigger picture of why you're doing things.
Great, great. But how about the modern days microservices approaches? Like, for example, in most companies, we realize that they are trying to use the microservices because it is trend. Okay, let's do everything using microservices. Let's use this cloud, Azure, I don't know, AWS, etc. So
Mm-hmm.
what do you think about it? Have you seen the software architecture evolve over the years, especially with the rise of microservices and cloud native applications?
Mm-hmm. Yeah, so I've been in this game for 25 years at least, and when I started, we had this thing going on called service-oriented architecture, so which was very very fashionable back then. And then everyone got, tired of that, and we sort of switched over to something that was a little bit more monolithic, if you will. And now someone came up with this idea of microservices. And then, so we have this pendulum swinging, and at the moment, it seems like it's going back to people are starting to talk about modular monoliths again, because microservices are not really that fashionable anymore. And I'm more like, yes, so modular monoliths, but you could have done that 15 years ago. And I would claim that I wrote code like that 15 years ago, but we just didn't call it that. So to be fair, it's not that, one is superior to the other in all cases. I think at least maybe not microservices. So originally when microservices came out, people were discussing, how many lines of code is a microservice? And someone said, well, it has to be less than 100 lines of code, which is ridiculous, because we haven't even stated which language we're talking about here. So 100 lines of C code is not equivalent to 100 lines of APL code. I don't know if you've ever seen APL, but that is a weird language. Me. Um, But anyway, so I think if we just dispense with that idea about microservices has to have a certain very small size, I think the one of the driving forces, as far as I understand, the original development of microservices was that companies like Amazon and also I think Netflix and perhaps also Spotify had started to realize that coordinating teams of thousands of developers is just really, really hard. Whereas if you can compartmentalize them into small teams and say, well, each team is just, I can't remember which companies they talked about a 2-person team, but we're probably talking about, 5 to 10 developers max. I would probably say I'd probably prefer rather 5 than 10, but maybe also with a bit of, other staff. Such a team, let's say 4 or 5 developers, a couple of other people around, to take care of the customer voice and so on. Such a team can maintain a useful standalone service. And then we can say, okay, should we call that a microservice? So we do that nowadays, whereas back in the 2000s, we just called them services or web services. But the idea is, so I think Udi Dahan calls these things, it's something with business capabilities. It's sort of like a standalone or a self-contained business capability. That's sort of the way you demarcate one service from another one. And that makes sense from a lot of, from a perspective of just trying to manage your software teams, because, you've read the Mythical Man Month, I suppose, but you can draw these, graph where you say if you add another developer, you add, it's I can't even remember if it's exponential or but it's something like that. You just have so much, coordination overhead. So having, some people call it the inverse Conway maneuver, where you go and say, we don't want to manage all of those, we don't want to manage big software teams. So we make small software teams that can act independently of each other. That makes a lot of sense to me. I mean, that definitely seems like a good strategy if you have lots of developers. And then the architecture, the service-oriented architecture, the microservices architecture sort of falls out of that. So it's not that you choose microservices architecture, you choose to do the other thing because your software development team is so big. And then that's sort of a very reasonable, technical solution to then your organizational problem, if you will. So it makes sense for me for that reason, but not for microservices itself. You can do modular software with just, applying good, software design practice in general, and we can maybe come back to that later on. You don't need to have microservices to do decoupling. You can definitely do decoupling within, a larger
architecture.
Oh yeah, absolutely. Yeah.
Yeah. But what do you think about this approach, starting from monolith, moving to microservices, or directly starting from microservices?
So you're asking if we imagine that we are being asked to create a new piece of software from scratch, and then where do we start? Yeah.
Yeah, exactly. Maybe the service-oriented architecture may be enough rather than using microservices.
But this again, I really believe that the important part here is to ask, how big is my team? So, I would do separate services if someone comes to me and asks me to create a new piece of software, and they tell me, Mark, you have 50 developers, you have to use all of them because we budgeted with that, and we think that's the appropriate thing. I would probably go and say, well, 50 developers, that's going to be a lot of coordination. So if I could somehow split that problem up into, let's just say if possible, I could split it up into 10 services. That would mean I would have 5 developers per service. And then that's the inverse Conway maneuver. That would mean that maybe those teams would be, self-organizing, and then they wouldn't need a lot of coordination. One could hope. There's no guarantee that it's going to play out that way, but I would seriously consider that as my first decision point. Okay, how big is my team? And then figure out, how do I decompose that team so that they don't need to have too much, coordination going on. So microservices could definitely fall out of that. But on the other hand, if you give me a team of 5 people, I would start with a monolith because a monolith is just so much easier. There's a lot of things you don't need to worry about, and not to the same degree, because every time you have service-oriented architecture, you need to deal with all sorts of problems that has to do with networking. And we know all those fallacies about networking where we say, yeah, well, it turns out in reality, a network hop is not instantaneous. The network will fail and all of those other problems that we experience. And we don't have those problems with monoliths. So if I only have a small team, then I'll start with a monolith and then see what happens.
That's great answer. That's great answer. In modern days, as you know, we are talking about mostly let's say the last 20 years, people started to talk about domain-driven design. Yeah. So my question is, how do you see domain-driven design fitting into modern software architecture practices? What's your honest thoughts about domain-driven design? Is that really makes sense, or we are doing over-engineering, let's say?
So again, I want to point out my focus on when I get involved, it's typically because I help people organize code bases. And I think it makes sense to say, well, instead, you might as well use some wording or some terminology in your code base that reflects what it is that you're working with. I mean, that makes a lot of sense to me. It's almost a little bit like why wouldn't you want to do that? I mean, it doesn't really strike me as being that much of I don't really think it's a big thing in the sense that it seems natural to, if you want to write code that is easy to understand and you can go in, and if you have a little bit of knowledge about what's going on in your surroundings again. So we come back to this thing again where you asked me, about before. If you want to be a mature, or if you want to get towards being a senior developer, you should probably be aware of what's going on around you anyway. So once you have that awareness, why not put that knowledge into the code? I mean, that makes a lot of sense to me. Now, I'm aware that I am downplaying the role of DDD a bit because I've been running into, in Europe, not so much here in Denmark, but particularly in the Netherlands and Belgium and Luxembourg and this, Benelux area and France as well. There's a very strong DDD community, and I've run into some of those people from time to time, and they're very good, very skilled, very intelligent people. And what they seem to focus on is also a lot of the knowledge gathering that's going on outside of the actual programming. We also have a guy like Alberto Brandolino, for example, who came up with this idea about event storming, which I've seen as a demo. I may have done a little bit of a workshop with it, just a pretend one, but I've never done it for real. It makes a lot of sense to me. So I'm not trying to downplay DDD because that looks to me that this is where DDD has now headed. So there's a lot of things going on in the DDD community that's not really related to Eric Evans' book, directly, because those people have actually invented a lot of new things on their own that builds on top of the work that Eric Evans originally did. And I think a lot of them, that seems extremely valuable. I mean, going into an organization that may not have a lot of technical expertise, but they have a need, they feel, that they have a business need, but they don't know exactly how to solve that in a technical way, and then trying to bridge that gap and using all of those techniques like event storming, that seems very valuable to me. It's just not something that I do that much of. So I'm trying to acknowledge that there's definitely a lot of value going on there, but I'm not really the one you should be asking about that because it's not really my core expertise.
Yeah, no worries. The case here is, I think, the best invention for me in domain-driven design was ubiquitous language because, as you know, we are speaking different languages. Business speak completely different language. Developers speak completely different language. So this ubiquitous language helps us to talk in the same language, and the same language reflects the business in our code, so anyone can understand the code. So because the business speaks and you're reflecting it to your code. And I guess this is one of the great invention for me in domain-driven design. So, yeah.
I think so. Just one little comment on this. We also need to be a little bit aware of, the history of where this comes from, because I believe now that the Blue Book, Eric Evers's book is about 20 years old now.
Yeah, exactly.
Something like that. Maybe a little bit more. 2004. Okay, so that's 20 years. And programming was done a little bit different there. So you had, Java had been around for 6-7 years, and C# had only been around for 2 years. And those were basically, those were the new languages around, but there were still a lot of programmers who would also be working in C or C++, languages like that. And that kind of programmer would often speak in what we could call very computer science terms. So they would talk about linked lists, or red black trees, or whatever else. They would be thinking in data structures. So I also think that the way that I interpret the Blue Book is also that it's also a reaction to what came before. And it seems quite obvious that you need to point out to people, if they're trying to talk to an executive, a business executive, and then they're sitting and talking about, cache eviction and red black trees or linked lists, then you just have a complete, miscommunication going on there. That makes sense. So highlighting that we need to speak the same language makes a lot of sense. But now when we have everyone these days doing either, object-oriented programming, or at least they want to do that, or maybe people are doing functional programming now. But these languages typically come with a lot of abstraction, functionalities built into the language, where it becomes natural to say, in object-oriented programming, for example, it becomes natural to name your objects after the business concepts that you're modeling. So I think this whole idea about ubiquitous language, not that it's not important. I think it's important, but I just don't see it as the end all be all. I think it's more like something that's maybe gone a little bit into the background, because it's fairly natural to do that now. So basically saying, why wouldn't you do that? I think it's, yeah. And you might sometimes run into people who are so technical minded that you still need to remind them that they should do that. But I think, most of the developers that I've run into now pretty much default to doing that. They find it natural to pick up the language that they're, the business domain that they're modeling, and then using that language more or less as it makes sense in code. So I have nothing against ubiquitous language, but I just think it's maybe not the biggest thing anymore. I think there are other things that are, you should probably highlight, like, all the process that goes into it, like event storming, for example.
Got it. Yeah.
Sorry that I'm long-winded, but on the other hand,
no worries. That's really great.
At least I don't really have a hard deadline, so we can talk for hours if you want to.
And that's great. Yeah, because I have a lot of interesting questions for you. Mm-hmm. So, how do you align architectural decisions with the team dynamics and organizational goals? So this is also really interesting questions. I guess this came from our audience, as I will meet with Mark Seemann. So I received this question. What do you think about this?
So we've touched on this already, and I've talked about the inverse Conway maneuver. So maybe you should elaborate a little bit on that. So Mel Conway originally formulated this hypothesis where he says the way that a software development team is organized, you will be able to see that organization in the way the code is structured. So basically, I can't remember the exact wording, but it's something like an organization will reproduce its organization in the structure of the code that it produces. And he has some examples of that, and it's not really a hard law or anything, but it's an interesting notion. And then the idea with the inverse Conway maneuver is to, go the other way and saying, if I want to have a certain kind of architecture, I should probably design my development organization in a particular way. So that's, for example, when we do microservices, we say, okay, so now we create those small independent teams, and we'll have them working independently, and then that, will then cause a particular kind of architecture to emerge, which one should hope. But you can, again, there are other companies that work a different way. I'm fairly sure. So I worked for Microsoft many years ago, but mostly as a consultant here in Denmark. Um, but I would be very surprised if Microsoft's the teams that are doing Windows and the teams that are doing Visual Studio and the teams that are doing Office, I'd be very surprised if they're small independent teams. So when I left Microsoft, what you often had those, you had small teams, but then you have, teams of teams and then teams of teams and teams and so on. So, a product team would often be thousands of developers, and that's a completely different kind of organization, and also, produces a different architecture of software. So you could say your Windows operating system or your Office suite is a completely different beast than some web-based microservice. At least the stuff that you install on your machine. But then again, if you're using, let's say, Google Docs, for example, as I know you did when you shared your questions with me, maybe that's a smaller team. I don't know how Google do these things. But the point is, there is this feedback mechanism between how you organize your teams and how the architecture of the software will turn out. I think it's quite important to be aware of that and sort of design accordingly. And sometimes you're giving a team structure and then you need to figure out, okay, so what, if I'm giving this team structure and I can't change it, it's probably a good idea if I came into as an architect then and just acknowledge that and say, okay, so there's certain architectures that are not going to work. If I'm giving 50 developers and I'm told you can't split them up, well, you can organize them into smaller groups, but you're not allowed to make them independent and self-contained. I would probably say, well, if that's the case, it doesn't really make a lot of sense to do microservices, because I'm going to need to do some coordination with them anyway. So maybe a modular monolith makes more sense in that case. So I would also consider what it is that I have to work with, and then try to find an architecture that makes sense for that, or vice versa. Does that even answer the question? I'm
Yeah, that's good. So, totally okay. Yeah, that was the exact question. I guess from the architecture and team dynamics, that's all. And let's switch to the interesting parts, dependency injection. Yes, my lovely topic. So, Mr. Seemann, you have brilliant books on dependency injection, principles,
thank you.
practices, patterns, and dependency injection in .NET. So, my question is it a silver bullet using dependency injection? Let's start from this question.
Oh, okay. No, it's not. It's not a silver bullet. I actually don't use the dependency injection that much anymore. I still use it, and I would probably say, well, unless I have a very small, piece of software, there will be some dependency injection in it, but I don't use it to the degree that I used when I originally wrote the first edition of the book. So the first edition of the book is from, I believe, 2011, and it took me 3 years to write it. So 2 or 3 years, and I did dependency injection for basically, I was DI all the things back then, and that's basically because that was the best way that I knew of back then. And then I've learned some other techniques that we can get back to later on that are often superior to using dependency injection everywhere. But it still makes sense to do some dependency injection. So a little dependency injection I do, but not to the degree that I did when I started out. So it's not a silver bullet. By the way, also, if you go and actually read the No Silver Bullet article by, so that's Fred Brooks, right? So the way that he defines a silver bullet is that you should have some sort of improvement that gives you an improvement that can be measured by orders of magnitude. And even if we would claim that dependency injection is universally good, it's probably not going to be an orders of magnitude improvement anyway. So it's not a silver bullet, but even so, DI is not a universally good technique. It's useful, but it's not universally useful. There are some disadvantages as well. I'm sure you probably want to ask about that, but we can get back to that.
So As developers, we really love to follow the trends. For example, in 19th, they invented design patterns. We started to follow design patterns, and we thought that, okay, if there are design patterns, it means everyone will write a code. That everyone will easily build application like a Lego. There is no need to learn more about programming. Then we started to talk about configuration-oriented programming. Everything in configuration, there is no need to write code. And the third level is going to be this type of dependency injection, dependency inversion principles. So Sergei Tepelkov mentioned in his book that we really love to follow these trends, but all of these, we should pay something to use something. If you bring something, you should pay something. What we are paying when we are using dependency injection, because there should be some complexities in the future. If you are actively using, you have a class which has 10, 15 injected classes. So what will happen in the future? How to maintain, how to deal with these problems?
Yeah. So as I understand you, the core question here is that there's a trade-off. You know, you're gaining something, but you're also losing something, or you're paying something. There's a cost associated with getting a benefit. Okay, and fair enough. That's true. I think. So first of all, so you mentioned, if you inject everything, if you have, I see that a lot, where people have classes and then you have 15 different services injected into a class. That's too many. Yeah. That's just too, yeah. But I call that, over injection for fairly obvious reasons. It doesn't really have anything to do with dependency injection. It's just too much, and in general. So if you go back to something like I believe it's clean code, or maybe it's there are books that talk about how many arguments are too many arguments, and often you will arrive at people who are much smarter than me will say, well, but 3 or 4 arguments are probably the maximum you should have, and if you have more than that, you should probably consider redesigning somewhere. And this goes for dependency injection as well. So if you have 15 dependencies is 15 arguments, which is at least 10, more than you ought to have. So it doesn't really have anything to do with dependency injection that you have too many. That's a different kind of problem. We'd be happy to talk about that as well. So I think the real cost with dependency injection lies somewhere else, and it's more that you are making things more complicated than they sometimes have to be. So David Heinemeier Hansen, DHH, he had a very interesting series of blog posts, like it's probably going to be 10 years ago now, called, it's actually about TDD, and he said TDD considered harmful, so test-driven development considered harmful, or something like that. He talked about test-induced damage. And the test-induced damage that he highlighted then was basically just doing dependency injection, because what you often do when you do, there's a style of test-driven development that goes hand in hand with dependency injection, where you write a little test where you inject a test double, a mock or a stop into your system under test, and then you can sort of control it that way. And that leads to constructor injection or other kinds of dependency injection. And then, DHH, who usually programs in Ruby, is the inventor of Ruby on Rails. He comes by and say, well, why would you write your code like this? If you have this particular problem you want to solve, you'd write these 3 lines of code. But now, because you've done all of this test-driven development, you now have all of this constructor injection going on, and that, now bloated your 3 lines of code to 10 or 15 lines of code, because you just need to have all of that infrastructure in place. And I think that's a valid argument. He highlights the cost of dependency injection, because he said, well, you wouldn't be doing that if it wasn't because you want to, in this case, be able to unit test it. And then I agree that far with him. And then he goes on to saying, well, you shouldn't be doing test-driven development, or you shouldn't be doing that kind of small-scale testing. You should be doing large-scale, behavior-driven testing, or, integration testing instead, which I agree also has its its benefits, so you should be doing some of that, but I don't think you should be only be doing that. So this is where I disagree with him, though, but I think the analysis is spot on. So I've seen lots of code bases where even if you can keep the number of dependencies down, so you only have 2 or 3 dependencies per class, you still end up having a ton of interfaces. So I usually look at C# code, but you just have a ton of interfaces, and every interface has exactly one implementation, and then it has a test-specific implementation that is often done with a dynamic mock library. But that's it. So once the number of interfaces grows, you end up having dozens of interfaces, maybe even hundreds of interfaces, and you completely lose the big picture of what all of those interfaces do, and then the naming the interfaces become difficult, and it also becomes difficult to, if you have a team working in this way, it also becomes difficult to actually recognize if you have an abstraction that you've already defined. So sometimes people will go and define a new interface, which is exactly the same as an interface that already exists in the code base. It just has a different name because they weren't aware that that interface already existed. So now you have that explosion of things going on, and obviously, you could go and clean it up afterwards, and I think people should do that. But that's definitely a cost with dependency injection. So that's why I usually nowadays say, so the short of it is that I think you should identify the real, extra process dependencies that you have. So if you have a database, this is something where you leave your own process space to talk to a system in another process. Or if you want to send an email or things like that, where you're leaving your own process space to send off bytes somewhere else. Those are architectural, dependencies. That makes sense to do dependency injection for those. And a few other things like the system clock, for example. But apart from that, keep it down, to that, and then find other ways to, make, if you want to make things testable, for example, we can get back to that if you want to. There are different techniques. So keep the DI,
as minimum as possible.
as minimal as possible.
As
yeah.
minimum.
Thank you. Yes.
Yeah, that's really great explanation. So the next question about dependency injection is this topic open for evolution? I mean, let's ask in this way: how had the concept of dependency injection evolved since it is first became popular?
Right. I think the most important things that started to come as a realization for people was that you don't need a dependency injection container to do dependency injection. And when I did the first edition of dependency injection, the book, the DI.NET, I started out with wanting to cover a lot of particular DI libraries, DI containers, and you heard about some of them. There was Castle Windsor and AutoFac and structure map and a few others as well. This was before it was nowadays in .NET, at least in ASP.NET, there's a built-in DI container, which I actually don't think is a good idea, but again, that's a side discussion. But as I wrote the book, I started to come across other people who were also in other languages trying to explain how DI actually works without a DI container at all. So I ended up writing the book so that the first 3 parts of the book are actually, explaining what dependency injection is without relying on any particular DI container. And then the last quarter of the book is basically just a catalog of the different DI containers you can do. And if I were to write a completely new book about DI, I would probably write it without mentioning DI containers at all, because I think it's not really the interesting part of it anymore. But I think that was probably the greatest realization but that happened like 15 years ago. That's an old realization, but I think that's probably the most important one. And after that, I haven't really seen that much new going on in that space.
Great. But why we are not preferring to use factories over dependency injection? Let's ask this type of question, because I can create any of these classes using factories, and for me, the dependency injection is also a variation of factory pattern, isn't it?
Yeah. So, so there's a different way you can approach that problem of decoupling, or for example, so dependency injection is often the reason why people often want to do it is because they want to make things testable, unit testable. It's not the only reason, but that's probably one of the most important motivations that people have. And there are other ways you could solve that problem. And you mentioned factory. There's actually no pattern called the factory pattern as such, but there's a well, not that I'm aware of. There's one called factory method, and there's one called abstract factory. The factory method is instead of relying on injecting dependencies in via the constructor, for example, what you can do with the factory method is you can have a little, virtual method that creates things for you, and then you can go and inherit from your base class and then create a derived class, and then you can override that factory method so that it would create something else. So instead of creating your real database repository object, it might create a test specific one instead of a mock or stop. So that's another way. That's not really this. It's not quite dependency injection. It's a different way of using polymorphism to reach the same, or to solve the same kind of problem, if you will. But it's not. I wouldn't really call that dependency injection. But they're equivalent in the sense that once you have one, you can refactor to the other one, so you can go back and forth. It's not that hard to refactor. So what I usually do with people is that if they have a lot of legacy code and they don't know how to make it testable, I often recommend that they start with the factory pattern method, or the factory method pattern, sorry, because it's easier to put that in place in a gradual way, and then you can make the thing testable. And then afterwards, if you don't like it, then now you have test coverage, and then you can go and refactor that to use dependency injection if you want to, but maybe you could also just leave it as it is. It may not be important. I think I lost track of your question again. I'm sorry.
Yeah, no worries. Yeah, that's completely okay. Yeah, I got the question, the answer to my question. So you think that dependency injection is a bit updated, let's say, version of factory method pattern, yeah?
Yeah, so
Roughly, somewhere.
Well, I consider dependency injection and factory method to be equivalent in the sense that it's fairly easy. So sometimes I use the word isomorphic instead, meaning you can go there are two different representations of the same problem, and you can go back and forth between those two ways of modeling things without losing, data. They're just two different ways of representing the same kind of structure, really. That's probably not entirely, there's probably going to be some mathematicians now that say, yeah, it's not what isomorphism mean. And I'm sorry that I misused that term. I actually also do know what isomorphic means in mathematical terms. And I'm using the word here in a little bit of a looser fashion.
Yeah. I really love this type of terms. So, the last question is about dependency injection. Is nowadays many developers just, let's say, misunderstood this topic, the dependency injection, and what are some of the most common mistakes or misunderstandings you see developers make when they implementing dependency injection? So you realize it, and you are saying that this is not a correct way of using dependency injection. Yeah, something like this. Yeah.
Yeah, I think so we touched on some of them already, and I think the most important one is that you don't need a DI container to do dependency injection. That's a very common misunderstanding that people come in and say, well, we want to do DI, which container should we use? Or nowadays people just say, we'll use the built-in DI container. And then they may even go and actually inject the DI container into their classes and then use that DI container from within their objects to then resolve services, which is generally not a good idea. So that's probably the biggest one. And then you yourself also mentioned the other trap that people often fall into, than just injecting too much. And really, I think, one of the things that actually is nice about DI is dependency injection is that it makes it easy to spot when your objects are taking on too many responsibilities. Because if you didn't do DI, if you didn't have constructor injection, for example, if you just imagine that we just use the new keyword to just create new objects whenever we need them, new services, you might not really have a single place that makes it obvious to you that now you actually have a lot of stuff going on in your class, because it just grows slowly. You add a code the one day and then you add a line of code the other day and so on. But on the other hand, if you have a constructor, if you use constructor injection and you inject all the services into the constructor, it's quite clear to you when you add the fifth one, for example. Let's just say that. So if you could have a rule of thumb. I would probably say already, if you have three, that's fine. When you feel the need to add the fourth one, that should at least be a trigger of contemplation. Instead of just going and say, okay, I'm just going to add this new, fourth dependency, you should stop and think, okay, is this really the right thing to do? And maybe go and ask a colleague and see what else can we do? This seems too much. But you should, but you could probably agree, I think teams should have some thresholds that they agree on, and more teams should have that. I don't see that used too much. But I think, a little team should have some design guidelines that they agree on. And it's a design guideline for me is not so much, it's not so much, what's the indentation, do we use tabs or spaces, or if we use spaces, how many spaces is an indentation and so on. Well, I do care about that too, but that's not really important. Or do we do, one very technical syntax thing over another one? Yeah, but you can always change those things. What I think is really important as a design guideline are things like this. Should we have some sort of, trigger where we say, if we add more than 4 dependencies to any service, we should now call for a meeting, something like that, or we shouldn't do that. Or we could have, other similar kinds of decision points where there should be some sort of alarm bell going off, saying, okay, you are now at the limit of where you should be. Go and have a talk with someone about this, because there's probably going to be a colleague who has good ideas. So I think a lot of, I see a lot of development organizations that are basically just on autopilot, if you will. So they never really stop and think about, is this really the best design we could come up with? They just say, well, I'm just banging away on the keyboard until it works. And once it works, I just, close my Jira ticket and say, can I have a new one, please? And I don't do that. I mean, I think, and the funny thing is, okay, so I'm sorry, I'm going off on a little bit of a tangent here. Let's see if I can do it quickly. But I think, people often come and ask me, they want to do the right things. They want to do good design, but then they say, but my employer will not let me do that. And I hear that all the time. And of course, I'm here in Denmark where the labor market is good and flexible and all sorts of. So I understand, in other cultures, things might work in a different way and so on. But I would still think, you're paid to be the technical expert. If you're the programmer, your employer is somehow trusting that you can make technical decisions, because you don't ask permission to create a new C# file, for example. If you think, oh, I'm probably going to need a new class to do something, you add a new file in your development environment and you find a good name for it, and you don't ask permissions to do that. That's a technical decision. And somehow you feel perfectly capable and competent of doing that. Now, if that's the case, why don't you feel, comfortable or capable of making design decisions that are a little bit more long-ranging? I think it's a professional thing to do, and saying, well, okay, yes, I've now reached the point where I have a working prototype. You could phrase it like that, say, yes, my code works. I consider that a working prototype. It's not the finished product, because if I just check this into Git now and close my Jira ticket and moves on to another thing, there will be repercussions of the way that the code is structured at the moment, because it's so difficult to read and understand, and it's so difficult to make changes to later on, then it's going to cost us. It's going to cost us more time in the future than it will cost me now to actually just, polish it off and make it nice. And again, I think, again, you need to have that, situational awareness of what's going on in your organization, because if you are, doing some, you have an emergency going on and your system is, your system is non-responding, and you have customers threatening to sue you because your system is not responding and all of that. Okay, maybe at that point you can just push whatever works out and say, okay, this is an emergency situation. We'll take the technical debt, deal with it later. Fine, situational awareness. But in normal circumstances, it often makes sense to say, this code here will have a downstream cost that is much larger than the, if I spend one more hour actually making it a little bit nicer now. And I don't know, I am not sure that I completely understand why everyone feels that they need to ask permission to do that. I mean, oftentimes our managers don't even know to that detail level what it is that we're doing anyway, because they don't understand programming. I don't know if that makes sense.
Yeah, exactly. But as a developer, for example, in some countries, when I worked with USA companies, they have the hour-based rating for the tasks. Let's say you have 4 hours to finish this task. So,
Yes.
And I need the fourth injection, and it indicates that something is wrong, and we need to divide this big service, let's say the service layer, the service into smaller ones to not to have the fourth dependency. So, but I have the limited time, and I can add it to technical debt. But the question is, what happened with these technical debts?
Yeah,
what will happen?
It never gets paid off. That's the thing. Yeah. No, so I get you so far as you can definitely create organizational structure and incentives that work in a way where people are basically being punished for doing the right thing, and I acknowledge that that's the case for some people, and I pity those people. I think it's really too bad that you actually have to work in situations like that. But on the other hand, I also understand that's the reality. I'm very fortunate to be living in Denmark and having a nice society to live in, and social security and all of that. So I'm completely aware that not everyone is that fortunate. So if you find yourself in a less fortunate place, then what I say is maybe not realistic, and I understand that. But then I basically don't know what to say then, because it's a structure that pretty much forces you to do the wrong thing. And maybe the only consolation they can then give you is to say, well, then don't feel bad about doing the wrong thing, because it's not really, it's out of your hands. You shouldn't have it's not your responsibility. It's you shouldn't feel guilty about it, because it's really been set up that way. So I acknowledge that this might be the case. I sometimes get that I've been doing a lot of consulting and traveling around and doing conference talks in Eastern Europe, and also in a previous life before the Ukraine war, I was also both in Ukraine and in Russia. And I get sometimes the impression in some of those cultures that it might be a little bit like what you just described there. So maybe. But on the other hand, I also run into a lot of people in American companies and European companies who ask the same question. And I'm not really convinced that all American companies are that rigid. I think also there's a lot of, people don't really want to take the responsibility. They want permission.
Great. Yeah. Thank you very much for answering. Yeah, it was my personal question.
Yeah. I hope I gave you something at least then.
Exactly. Fair enough. So let's switch to the functional programming. So dependency injection and functional programming.
Yeah.
What is how dependency injection fitting into the world of functional programming. Of course, I don't use any functional programming language. Sorry about that. So I'm just using a C#.
That's okay.
Yeah, but I know you're expert on F#, and you're actively using functional programming and writing about functional programming. So my question is, how the dependency injection fits into the world of functional programming?
Yeah, that's easy. It doesn't.
It doesn't.
It doesn't. So of course it depends on how you define functional programming, and what I usually do is that the way that I try to give a definition that's fairly objective. And one of the things we can do here is that we can distinguish between two kinds of instructions, if you will, language instructions. And in functional programming, we like those things that we call referentially transparent functions. So referential transparency basically means that the expression that you use in order to arrive at an answer and the answer itself are replaceable. So you can think about, so when I say expression, it could be many lines of code that, do all sorts of calculations, and it might, it doesn't have to be just numeric calculations, but it might be all sorts of things, string manipulations, algorithms that, determine outcomes based on complicated, complex data structures. But as long as we can say, well, if given a particular set of input, this particular algorithm or this particular function will always produce, if we give it the input 1, 2, 3, it will always produce the output 4 to 2, let's say. And that's always going to be the case. Now, if we give it, 3, 4, 5, 6 as input, it'll give us, another number like 55 or something like that. But then it will always produce, those inputs will always produce the same output. So if that's the case, and also if there's no side effect, if that algorithm doesn't, fire off emails to your boss or whatever it is, then we could take and say, well, if we know that the input is this, we don't really need to perform the calculation. If we've done it before, we could just replace it with the output that we already know that this input, 1, 2, 3 is always going to give us 42. There's no reason to actually run that calculation if we already remember that the answer was 42 because we did it once already. So that's referential transparency, meaning you can take your complete, big algorithm, all of your source code, and you can basically just say, yeah, that input is always going to produce that answer, and we can just replace running the code with the answer. So this is known as referential transparency. Also, some people call it pure functions. And in functional programming, we'd like to have as many of those as possible because there's a lot of, these things come with plenty of benefits that we can go back to if you want, interesting, but they're attractive for a lot of different reasons. And then there's going to be a complementary set of operations that don't have that quality because either they will be non-deterministic, random number generators are, obvious examples of that. But they're going to be either non-deterministic or they're going to have some sort of side effect. You write data to a file or delete a row from a database, something like that. That's a side effect. So we understand that these things also need to take place in order, otherwise you can't have an interesting piece of software. But we just want to minimize the things that are not referentially transparent. Now, so the thing is, you can't, if you have a referentially transparent piece of code, a function, and then you decide all of a sudden that, hey, I also want to delete a row from a database from within that function. Now, that function is no longer referentially transparent. So you can't do something that is what we call impure from within pure code. And the thing is, all the stuff that you tend to do with dependency injection is exactly all of those impure things. So dependency injection is often because you want to abstract away your database, or you want to abstract away your user interface, or you want to abstract away the system time, something, those are very common examples. All of these are either side effecty or non-deterministic. So you can't inject things into pure functions because if you do that, the pure function is no longer pure. So you need to find another way to do that. But basically dependency injection and functional programming does not work. That's, you have to choose one or the other. there's some ways out of that, but we can get there. I feel I've talked long enough already.
Really good answer. That's really good answer. Thanks. So, about the functional programming, and in modern days, I guess it is for me started about 6, 7 years ago. I started to apply functional programming in C#. So we started to use something like the result parent to not the throw exception, to return the values, all sort of things, the null parent. And so what is the real value of applying this functional stuff to the world of, let's say, object-oriented programming?
Mhm.
C# not completely object-oriented programming, but
Mhm.
anyway, it is a general purpose language. Let's say it has the object orientation, functional, etc. So what what functional programming brings to the
Mhm.
table of object-oriented stuff?
So this answer is going to be a little bit abstract because I think this is actually a really difficult question to answer in a convincing way. If I find a more convincing answer than the following, then I'll switch to the more convincing answer. But I haven't found anything that's more convincing. That what really convinces me is that in general. So I already explained referential transparency, and I think one of the really interesting things that fall out of that is that because we can say you can imagine that you have a fairly complicated algorithm or something else going on that's actually does a lot of work, but then if it's referentially transparent, it means the return object or the return value that it returns is equivalent to all of that stuff going on. And that means you can basically think about that complicated operation as being equivalent to just the return. Let's just say that it returns an object, that the calculation and the object are equivalent. And this is pretty much what we want from abstraction. This is what the original idea about object-oriented programming was, to say we want encapsulation. And the idea about encapsulation is that we don't want to, in order for us to be able to use an object, we want to be able to use the object without understanding the implementation details of how that object is implemented. And this is exactly what you get with preferential transparency, because now it becomes the object is equivalent to the calculation that produced the object. And that should mean, in theory at least, that unless you actually need to go and change the algorithm, you don't need to understand all the details of how that object was created. You just have that object that represents that idea. And because it's referentially transparent, it's actually guaranteed to be a good abstraction, because it abstracts away all of that stuff. So you don't have to worry about it. It's a little bit, to give you an example that most people probably run into. I think a good example of encapsulation that actually works in this way are your typical, security or encryption algorithms. So you probably run into some of those from time to time, where you need to set up some encryption stuff or some security, combined with, you need to implement some login thing or whatever. And you probably just read the documentation, and then sometimes you figure out by reading the documentation, oh, I need to create this particular object, and it has to be an HMAC SHA-256. I can't remember what they're called. I'm sorry. I have to look it up. But I had to look it up, everyone. And then you feed it in, an array of bytes, and then you say, please encrypt the string for me, and you get an array of bytes out. And this is a perfect example of exactly what I'm talking about. This is actually, those encryptions are actually, referentially transparent. And I'm sure that most of you who've done this, including me, have no idea how that encryption algorithm works. And you don't need to know, because it's so well encapsulated, because it's referentially transparent, it's deterministic, it has no side effects, that you don't have to know. You don't need to care about what's going on inside that black box. It just does what it is that you need it to do. And functional programming is basically writing as much of your code in that way as you can.
Exactly. Great. But how about the documentation perspective? For example, when you, for example, we have the classical layered architecture. We are using, let's say, services, and my service in one case may return an object or throw exception, or just return a result with object and string error, let's say, in a concrete manner.
Yeah.
So from the documentation perspective, what do you think about it? Is functional programming more descriptive, more describes itself rather than the classical writing style we use when we throw exceptions or etc.?
It's that really depends on the language, because so far we haven't. So you talked about C# and the functional features that C# comes with, and there are definitely some things to be gained from that. But they're different. There are lots of different functional programming languages, and if you want to draw a line, basically saying what are at some of the extremes, you can say, well, in one end of the line you have something like Closure, which is a Lisp that's running on top of the JVM, and it's dynamically typed. So that means that when you need to understand a function that you want to invoke in Closure, you have to go and basically look up the documentation and see, okay, what kinds of inputs does this thing accept? What will it return? How does it deal with error and so on? And if the documentation doesn't tell you that, you're pretty much lost, or you have to experiment by writing some tests or using the so in many functional programming languages we have these things called the REPL, the read eval print loop. So C# does actually, there's something called C# interactive, but no one uses it, and it's fallen a little bit by the wayside now. But in Closure you will see lots of people just doing small experimentations on a command line, just writing little expressions, and then if the documentation doesn't tell you, you can often figure it out by just making small experiments. Oh, by the way, this is another benefit of pure functions, is that a pure function is self-contained, and that means you can just experiment with small bits of code in a command line or in this read eval print loop, and just write some expressions and see, call some functions and see what they return, because there's not a lot of scaffolding or a lot of context you need to set up, because they're self-contained, because they only deal with the input that you give them. Well, so that's one end of the spectrum, and then on another end of the spectrum, you have various, purely functional programming, like language like Haskell, for example, which is also has a very strong type system. And in Haskell, you can often just go and have a look at the type of a function, and then you can get a pretty good idea about, how does this thing actually work? Which inputs will it accept? What do I need to deal with in terms of return values? And C# and Java also fall somewhere in the middle between these things, because you have a static type system in C#, but it's not nearly as powerful as the one we see in Haskell or in F# even. So you need to resort to a combination of, you can use the static type system in C# for quite a few things, but there are also things it can't really tell you. So what I often find, just to complete the answer here, is that if I write things in a functional style in C#, as long as I stay within these things, I can often understand what the functions do by just looking at the types. But on the other hand, as soon as I need to interact with something that's part of the base class library, it always surprises me with then it throws an exception, or then it returns null, or whatever it is, and it does all sorts of things, and it's really unpredictable. So I think taking and writing in a functional style, even in a multi-paradigmatic language like C# it makes your own code more predictable, and there's definitely a benefit to that, as far as I can tell.
That's really great. So we're talking about the functional programming. So my question is why F#? So why F#? And when you prefer to write in F# rather than using the popular ones like C#, Java?
Yeah, so F# is functions. Dunsheim, the inventor of the language, calls it a functional first language because it's multi-paradigmatic, just like C# is. But C# started out as an object-oriented language and got, functional features as it went along, and a lot of those features are inspired by F#. Let's put it that way. No, that's not a secret, and Mads Torgersen will tell you that, very publicly. He's very honest about where he gets his inspiration, and that's often from the F# language. So a lot of the modern features in C# actually comes from F#. F# is functional at first, but it also does object orientation. So if you can do that, but it just has a different emphasis. And then there's a little bit of there's things you can do with the F# type system that extends what you can do with the C# type system. So the type system is more powerful, and it means it gives you some modeling capabilities that you don't have easy access to in C#. But really the thing is, if you start becoming interested in functional programming, there's probably going to be a time sooner or later where you run into various different kinds of problems where that there's a nice functional solution to those problems, but now the C# language starts to be in the way. And it's not that you can't use C# to solve functional programming problems in a functional style, but it just becomes a very foreign way of writing C#. So sometimes I see people coming to me and they say, well, we'd really like to write in F#, but they can't because our managers will not let us do that. And there might be rational reasons why your managers don't want to let you do that. So, but anyway, so they say our managers don't want to let us write in F#, but we really like functional programming, so we're just going to do it in C# instead. And I've seen some of that code, and I've written a lot of it myself. I've mostly written it just for study. To teach myself stuff. But I've seen production code written in this style as well. And I've talked to a former colleague who did that as well. And he said, yeah, so this was a project that I originally was involved with. And then he came on and we worked together for some time. And then I left because I was a freelance consultant, and he stayed on for a while longer. And they just kept on pushing C# and making it more and more functional. And then sooner or later they reached a point where then they had a new C# developer coming onto the team, and this C# developer was, for all intents and purposes, an experienced C# developer. He'd be doing C#, let's just say, for 10 years, so definitely not a junior developer. And he looked at that code base for 1 or 2 days, and he said, I have no idea what's going on. I quit, because it was written. So I looked at it, and because I know all these functional programming idioms and all the patterns or whatever you want, it made a lot of sense to me. But it's just a completely different way of writing C#. And I think, if you do that, you're basically just doing the worst of both worlds, because you're using a C# in such a way that no one really, very few people understand what it is that you're doing with your C#, because you're doing functional programming, but you're not using a language that's actually designed to do functional programming. So the things you're doing that are actually quite hard to do in C# will be easy and idiomatic if you pick up the right language. So in .NET, it would be F#. On the JVM, it might be Scala, for example, or if you want to do Clojure, you can do that as well. But then, if you actually decide as a team that you want to adopt that style, I think it makes sense to say, well, it really makes sense to also then adopt a language that, where that style is idiomatic. And that might mean then say, well, we have a lot of C# code already. Okay, fine. Leave the C# code in place. But then if you decide to do new code bases, you might decide to do that in F# instead. I mean, I would definitely do that. I think F# is a better language than C# in general. There might be some niche reasons why you might want. If you're doing a lot of UI, particularly if you're doing a lot of, I don't think many people do that these days, but rich client things, with either Windows Forms or Windows Presentation Foundation, things like that. I think maybe it's MAUI these days, but it's still based on the same sort of programming paradigms. They're so designed so much to be C# centric that if I had to do something like that, I would probably still pick C# simply because the library, the framework that I need to work with expects me to do that. But for any general purpose code or for any web service or whatever, if you ask me, Mark, when would you pick F# and when would you pick C#? I would just go with F# every time because it does everything that C# does, but simpler and easier. It's a newer language also, so it's not really that surprising. F# came out in 2008, the first version came out, and it was fairly rough around the edges, and you can say C#, the first version of that came out in 2000 or 2001 maybe, but had been designed, had been in development for 4 or 5 years before that. So roughly speaking, F# is 10 years younger than C#. Yeah. So there's a lot of design decisions that they made in C# that done time you obviously could go and say, yeah, we shouldn't do that in a more modern language. And I think if you ask Mads Torgersen, he would probably also say, yeah, the decisions that we would have made differently if we've known what we know today. But you have to live with that legacy. But again, choosing F# is always, this is one of the things where even if I say, well, you're the technical person, you should make technical decisions. This is a kind of decision where I still would go and ask my manager, because the manager has some other concerns, like can I find other developers, and that's an honest concern, and I think you should have discussion about that. So don't just go and make that decision. You need to involve other stakeholders as well. But I definitely think F# is a better language.
Yeah, that's great. But why these functional programming languages are not so popular? Of course, I'm using the object-oriented stuff, and always when I'm looking for an interesting opportunities, I see that they are looking maybe the mostly C#, Java, maybe Go, etc. But
yeah,
unfortunately, not too much about F# or other functional stuff.
Yeah.
What do you think about it?
So I have let's say I have an optimistic and a pessimistic answer to that.
Okay, let's go.
Which one do you want
go
first?
for optimistic with.
Okay, so the optimistic answer is that I believe if functional programming in general solves more problems than object-oriented programming solves. So I think the optimistic view is that it takes a lot of time to actually get people used to a new paradigm, a new way of thinking, and my hope is that we're just not there yet. If you look at the time it took for object orientation to actually catch on, that also took between 15 and maybe 20 years before it actually caught on. People started talking about object-oriented programming back in the 70s or maybe even before that. And it didn't really catch on until mid-90s. There was stuff going on with C++ before that, but I think you could probably question how object-oriented early C++ really was. But I don't know. I haven't, I actually didn't program back then. Despite my age, I was a late starter in programming. So you could just say, well, so functional programming has also been around for a long, long time, but it hasn't been practical for that long, because there's some things about functional programming where it does, or at least it used to require more processor power and more memory than your typical imperative code. And that said, these days we have such sophisticated functional programming compilers now that's not really the case anymore, but it used to be the case. But anyways, but the notion that we should be looking at functional programming as a mainstream programming paradigm is much newer. So the optimistic, answer here, my hope is that we're simply not there yet, but perhaps with a new generation, we might get people who are more attuned to that way of thinking, and then maybe it'll catch on. That's my hope anyway. Do you want the pessimistic answer as well?
Yeah, let's go for it.
Well, the people who have pointed out that some of the object-oriented programming, or the ostensibly object-oriented programming languages out there, like C#, for example, but also Java, that they are good enough that the extra benefit that you actually get from switching to something that is completely new and different is just not worth it. So a lot of people just stay with their C# or their Java because they consider, and this may be rational, they just look at functional programming and they say, I need to invest a lot of research time, or I need to invest a lot of time learning this new thing. And okay, maybe it's going to make me a little bit more productive, but it's not going to be comparable, or it's not going to balance out with the cost of actually learning this new stuff, because C# is good enough or Java is good enough. And then don't get me wrong, C# is a really good language. I just think that F# is just an even better one. But C# is a really good language, and the tooling you have around C#, in Visual Studio and so on, is absolutely astoundingly good. Sometimes I really wish that you'd have tooling for something like Haskell that would be as good as C#, and it would completely blow everyone away. But then I also realized that if you look at something like C# and Visual Studio, this is something that a team of 1,000 people have been working for 20 years on. So it's not a small investment to get there. It's a really, really big thing. And so the pessimistic thing is that's probably just what we're going to end up with for the rest of eternity, because it's good enough. And don't get me wrong, C# is a nice language, so it's and you can do functional programming in it, and you can also you can even do a kind of functional programming that doesn't look foreign to other people, or doesn't look too foreign to other people. So that's a little bit of an art to do that, but it's possible to do it in a way that doesn't look completely off-putting. So we can get by, but the answer is pessimistic, in the sense that probably means that we never really get to mainstream functional programming, which I think would be sad, but that's a very, very real possibility, I think. Yeah. So I don't know if that answered your question.
Yeah, exactly. That's really the answer. But the last question about the functional programming is, when you prefer to use the direct F#, let's say you're started to work on a company, work for a company, and that are the reasons to choose F#, not to go with C#.
So basically, I think again, I'm probably repeating myself here a little bit, but I think if you don't have any other constraints, F# is a better language than C#. You can essentially do everything you can do in C#. You can do that in F# also, with a few exceptions. We can get back to those, and then you can do a lot more in F#. So why wouldn't you pick the language that enables you to do more things than you can do in C#? So that's if you don't have any constraints at all. And then there's a few exceptions to that, and I talked about that already. If you have a library or a framework that expects you to have a very object-oriented style, and maybe even expects you to have C#, then you should probably go with C# for those kinds of things. In web development, for example, also you have these things called Razor pages in ASP.NET. Yeah. And Razor pages has the syntax where you can basically embed small islands of C# in it, and you can't embed small islands of F# in it. So if you want to use Razor pages, which is a mainstream technology, you need to work with C#, at least in that part of the code base. Mm-hmm. So there are exceptions to the rule of going with F# always, and that's one of the exceptions. If you have a library or a technology that requires C#, obviously you have to do that. But that's if you're completely unconstrained. This is if you can, if you have programmers where you can imagine that they know F# just as well as C#. And I think if you have that kind of programmer, they'd probably pick F# as well. But then again, if that's not your situation, if you have other concerns, if you have a lot of C# developers, and they don't want to learn F#, then you shouldn't go with F#. You should stay with C#. But I've heard about other organizations where they said, we have a lot of programmers, and they've been doing all sorts of different things. We have some Python programmers, and we have some Ruby programmers, and we have some Java programmers around. And we've decided that we're not going to use any of those languages, because for other reasons we want to be on .NET. then you might actually run into a situation where it also, for that reason, makes sense to go with F sharp. Not because, they wouldn't know, they don't really know either F sharp or C sharp, but I think one company that did that is I'm not sure it's around anymore, but it was a big case study a few years ago, Jet.com, which was a startup that tried to compete with Google, with Google's marketplaces. And when you search for, I want to buy, a case of beer, or whatever, and you can search for Google, where can I get some good prices on that? And then Jet.com could give you some quotes where they were actually better than the ones that Google could give you itself. And as I remember that story, they exactly came from that situation where they had a lot of programmers with very different backgrounds, and they decided, they actually did some prototypes where they tried it out in either C sharp and F sharp, and then they ended up deciding to go with F sharp for some of the reasons I already outlined, but also because they asked those people who came from all those Python, Ruby, whatever backgrounds, and they knew that they had to learn a new language anyway, and they were more keen on learning F sharp than actually learning C sharp. So that sometimes happens as well. But it's really a complex discussion where you need to take in a lot of different
things into consideration.
You need to take a lot of things into consideration. Yes, thank you. And hiring is definitely often a concern. I hear that a lot because people are very concerned. Okay, so if we decide to choose F sharp, then how are we going to find new programmers? And yeah. I understand that concern, but on the other hand, I was once talking to an architect in the biggest bank in Denmark. He'd hired me to come in and do some F sharp tutorials for them. But he was also very interested in Haskell, and he just said to me, once when we were just talking, and he says, "Well, it's easier to find a good Haskell programmer than it is to find a good Java programmer."
Oh,
so the point being, yes, there are orders of magnitude more Java programmers, but a lot of them, that's his words or his implication, but not mine. But his implication is, yes, you can find a lot of them, but most of them are not very good. And that might also apply to you could probably extend that to C sharp as well. Whereas you say, well, if you can find a Haskell programmer, that programmer is probably going to be fairly good. Not because it's a Haskell programmer, but because it's a niche language. And the same thing probably goes with Clojure programmers or F sharp programmers or some other not very popular language, because the people who actually know these languages are not doing it because it's mainstream. They're learning those languages because they're interested in learning programming languages. And that probably correlates fairly well with them being good programmers in general. So there's that funky conundrum sometimes where I've definitely heard people saying it's difficult to find F sharp developers. And then I've heard other people saying it's easy to find F sharp developers because at least in some areas, at least, and I think this goes for Copenhagen, for example, if you advertise that you want an F sharp developer, and if you also write in your advertisement that you don't have to be an F sharp developer already, if you're interested in learning F sharp, we will take care of that for you, but you will be writing in F sharp code. That's actually an attraction to a lot of people. So you can actually get people to apply for a job just for that reason, because they want to write F sharp, and you can probably attract people in the same way if you advertise with Clojure and so on. But then I've heard other people who are in different areas of the world who told me, yeah, we've tried that, but it's just hard. We can't find anyone because no one does that in our city, and no one seems to be willing to run the risk of learning that new language because it's safer to just stay with C sharp or stay with Java or stay with C or whatever it is that you're doing. So it's there are regional variations to that. So it's not a one size fits all thing.
Yeah, exactly. Thank you very much. It was a quite deterministic answer to my question, let's say. So the last section, I guess we are a bit out of time, but I should ask these questions.
Yeah, thank you.
Fine. Yeah, because I want also to learn more about your books and writings. So this section is about books and writings. So
Mhm.
my question is, what inspires you to write your books on software development and functional programming? What's the real the idea behind writing all this stuff, your
Mhm.
blogs, your articles, your books, especially?
Mhm. Well, it's so it started out in one way, and now it continues for a different reason. But originally, when I was about maybe 5 or 6 years into my software development career, I'd been to a few conferences from fairly early on, and I've noticed that there were certain people that were speakers at conferences, and they tended to be, I saw them at one conference, and then I would go to another conference, and then they would be also speaking at that conference. And I thought, oh, that's interesting. They, point one, these guys, almost always men, seems to know a lot about software development, and also they seem to be, well regarded as being, not just me, but a lot of people seem to regard them as being experts in the field. So I thought, I want to be like that, because that seems like a good career move,
Oh,
because I was never very interested in becoming a manager. I was definitely ambitious, but I wasn't really interested in being a manager, because when I look at what managers do, is they talk on the phone or they're in meetings all the time. And I
mm,
love writing code, and I love solving technical problems. And I'm not particularly, keen on being on the phone and being in meetings all day. So that just didn't really look attractive to me. I thought, oh, this, being a technical speaker, that looks like the thing that I want to do. So I started out trying to do that, with local user groups and so on. Um, and then I also got into, I started blogging, also just because originally I thought it might be another way to get your name out and become known as an expert in things.
exactly.
This was back when, if you had a blog, that was pretty much interesting, but just by that, Microsoft actually had, I worked for Microsoft back then, and Microsoft actually had a list of all the Microsoft bloggers that they had. And I just started using Microsoft's blogging platform. So MSDN blogs, so blogs.msdn.com was the
Yeah.
original URL. And so I started that also with that goal in mind, of just becoming a more, known public figure, and a known public expert. So that, and also I was a consultant. I was working as a consultant at the time. So that all of that actually just, fit together fairly well. And while I was blogging, I then became into. I started doing some review work for Manning Publications.
Mm.
So not writing for them, but just reading other people's books, and giving feedback on those. And then one day they contacted me about this idea they had with a book about dependency injection. And I thought about it, and I could sort of feel uh, from the pitch that they had, it didn't sound like they had an author, because before that, sometimes they'd ask me to do, give my thoughts about a particular pitch that they had, and that would usually be an author associated with that particular idea. But here there was no author associated with this,
Mm.
so I thought, okay, um, they're probably looking for an author as well. So before I had the meeting with them, it was just a phone meeting. I started thinking about, okay, so if I were to write the book, how would I actually go about and do that? What would the general outline of it be? What would be the sort of narrative structure of it? And we talked, back and forth, and I said, if I were to do it, I'd do it like that. And then, the editor obviously said, oh, would you be interested in writing it? And I said, yeah, I could probably do that. And I said, okay, you're hired. And it pretty much works like that. And in technical writing, it still works like that, because you have to understand one thing about writing a book about software, is that you can make more money in other ways, or at least directly. If you look at the direct income you get from the book, it's not a good return on your hours by a long shot.
Exactly.
And I was even fortunate that the first book, Dependency Injection in .NET, sold really well. Um,
My
so
congratulations.
yeah, no, I've been fortunate enough that the books. So that one is actually the one that sold the most still, but the other ones are selling quite well also. But so I had decent income on it, but still, if you look at my hourly wages, compared to how much time I spend on it, I should just have done consulting instead. I would have made
No.
me much more money. But then there's another kind of income you get from it, because once you start, or at least back then, I don't know if this is true anymore, but back then, once you're a published author, you sort of enter another level, if you will. And then it becomes easier to become a speaker at conferences, and it also becomes easier to become a consultant if you want to go freelance, which I eventually did. And there's a lot of things that sort of come with that, and people want you to come to at conferences, and they want you to come to and give workshops, either at conferences or internal workshops at companies, and they pay you for that. So there's a secondary income from that, but that's why I started out doing it. But along the way, I just realized that I actually like writing. So that's actually my main motivation now, is just because I like writing. And now, if I look back on it, I've actually always liked writing, because even when I was, just a boy and I just learned writing, I would be writing stories just, in handwriting, in small books and so on. It's just writing. I tried to write a fantasy novel when I was maybe 6 or 7 years old,
Great.
because just in the style of, Lord of the Rings, stuff like that. And I think I filled in 3 small booklets of, just those things you get in school that are intended that you should just do your, handwriting exercises in. I filled in one, wrote another one, filled in that one, wrote another one, and so on. And then I sort of, just ran I just, ran out of energy with that. But, and I don't think I have them anymore. And of course, they weren't any good, but I just liked writing. So I've always come back to that. So it's fairly natural to me when people come and ask me, Mark, would you write something, please? And I just, yeah, I can do that. That's fine. It's for me, it's my natural thing. I also do public speaking, like on conferences, for example, but that's a much more unnatural thing for me to do. I do the best that I can with my conference talks, and some people seem to like them, which I'm grateful for. But it doesn't come natural to me in the same way that writing does. So writing is just my way of getting my thoughts, and also developing my thoughts. And it's still work. So I do like to occasionally become compensated for it. So it's not that I'm just writing books and giving them away for free. I still like to have, make a little bit of money on them, but it's not really my main motivation anymore.
Oh.
So, yeah.
Oh, that's great to hear. So, but what about the future plans? Are you still working on a new book, or any plans for the future to write something new?
I'm thinking about a third book now. So, and it's probably not going to be surprising. It's going to be about functional programming.
Oh,
and I don't really
great.
want to say more about it at this point, because I haven't started writing it. I'm still just thinking about the overall structure of it, and I have a lot of other things on my plate at the moment. So it's not a good time, for me to start writing a new book right now. But I definitely have this idea that I'd like to do, but it might be a couple of years before I start writing that, because I'm still writing my blog, and the blog publishes now every week. There's a new article every week, and some of those articles are actually pretty long. So
Exactly.
I don't know what people actually think is going on here in the little home in Copenhagen, but I probably spend between 15 to 20 hours a week just thinking about writing stuff. Between 10 and 20, that's probably more realistic. I've spent a lot of time writing, because the blog posts it's not always that they're just the articles. Often there's a lot of source code that follows along, and I need to develop that source code as well. And again, it's a labor of love in the sense. So the blog is actually something that I do publish for free. I don't expect anyone to pay me. So a few people are kind enough to, sponsor me, to, by buying me a coffee, if you will. Yeah. I'm very, very grateful for that. But I don't do that for the money at all. I do it to, well, there's a couple of reasons. Sometimes I I just run into the same questions over and over again. People keep asking me common questions, and then I think, okay, this seems like something that a lot of people will probably have a benefit out of. So now I'm just going to write a blog post about that, and then I can sort of point to that whenever people ask me that question, say, oh, I actually have a thing where I elaborate on that already. So maybe that'll help you out. That's one of the reasons why I write, and then I write just to develop my own thinking. So a lot of the stuff that I've been doing of functional programming, for example, has basically just been research, and you learn a ton about a topic by writing about it. So that's my motivation for some of the other articles. And it occasionally happens that I publish an article and then someone comes by and says, yeah, Mark, that's actually wrong. And then I have to go back to and make an edit into the article and say, yeah, okay, so I've just been pointed out to me, this is actually wrong. And I believe that the person who told me that is correct. So I'm leaving the article up for historical reasons, so you can see that I'm not perfect. I make mistakes, and I'm happy that someone is kind enough to point out my mistakes for me. And it's really painful every time that happens, but I still think, okay, it's important to go back and say, yeah, this article, don't trust what it says. I made a mistake. And here's why I made the mistake. That happens.
Truth be told, I am not agree in this case because not just me, but I know a lot of people who think about you like a true expert. And we learned a lot of interesting stuff from your blogs. And one of the impressive topic for me was the leak abstractions on your blog posts. And I really love this topic. So I'm also writing some blogs, not as professional like you. And I know it takes a lot of time, but for you, I think it is too much. Maybe what do you think about it? Yeah, maybe you can. I know some guys who takes their blog posts and publish it as a book. Maybe you can also work on that. What's your thoughts? Is there any plans like this or?
No, I have. Yeah, I've thought about that, but I think I don't really think it makes a lot of sense because, well, you could just, you could take. There's an RSS feed and an Atom feed on the blog, so you could just take all the articles and turn them into PDF and publish them if that's what you wanted. I'm not saying you planning on doing that, but someone could do that if they wanted to. I could do that, but I don't think it's interesting in the sense that. There's no narrative structure to the blog. It's been going on, my blog has been going on for so long now that if you go back to the beginning of the blog and look at the stuff that I wrote about back then, there's not a lot of that I find particularly interesting anymore. There's a lot about this. I made this test specific library called AutoFixture, that I'm not using anymore because I found better ways of solving the same problem now. Not that I think AutoFixture is a horrible piece of software, but I'm actually quite proud of it because I've made a fairly successful open source project out of it. But more about, I don't think in that particular way anymore, and I don't use AutoFixture anymore. So I wrote a lot about that. That's just to give you an example. And it's not really something that I find, for me at least, it's not really something that I find particularly relevant anymore. And then also some of the other articles, you can find articles that go into very specific details about a particular technology that was around back then. And, I'd run into a bug or, problem, and then I found a solution, and then I, documented my solution. And I, distinctly remember, for example, there was something once called the sync framework. So Microsoft had this little framework that could enable you to synchronize data between different data sources. So if, for example, you had a little, let's say you could host a little snapshot of a relational database on your mobile phone, and then you could have a real relational database in your data center. And the idea was that the mobile phone back then would often lose connection to the cell network, and you could make changes on your app on your mobile phone, and then once you got into connection with the cell tower again, you could synchronize the changes that you'd made with the database in the data center, and everyone else could do that. So your typical traveling salesman kind of scenario. That framework is not around anymore as far as I know, or maybe it is, but it's definitely, almost certainly been discontinued. But I ran into problems with that, and I found the solution and I documented that. And that's a blog post you can find as well. So you find those things as, if you go back. So at least if someone wanted to turn my blog into a book, you'd have to go and do some sort of curation. You have to pick out and say, okay, so this article will actually go into the book, but this one is not going to do that. So you need to make an effort of actually picking the ones that actually make sense. And
yeah,
there's probably parts of the blog where that would make sense. I have a very large series of blog posts. It's actually originally called From Design Patterns to Category Theory, which is not a title I like these days, because I realized category theory is probably not really the right term to use there. But anyways, that's I think that's entire series. It has a table of contents with sub-series, and some of the sub-series is sub-series of articles. And I think if you count them all, there's about 100 articles in that. And that might be a candidate to turn into a book if someone wanted to do that work. But then again, I'm still working on, occasionally I write a new article, even that I slide into that, series of articles. And once you've made a book out of it, you sort of stuck with that snapshot, if you will. I'm not entirely opposed to it, but it's not something that I have plans for myself. So there's a guy called, and I'm probably going to butcher his name, he's called Igal Tabachnik, something like that. And he'd made that kind of work with, there's a blog, there's a guy called Bartosz Milewski, and he has a fantastic blog series about category theory for programmers. And Igal Tabachnik took that entire series and turned it into a book. And he did a lot of work with making the PDFs look nice and so on. And he kindly asked permission by the author, and the author said, yeah, well, the blog is already free. So if you don't make money on it, then I'm cool with that. So I have that book now because he made it in a way where you could get it as an ebook, but you could also actually get it as a print on demand book. Mm-hmm. So I have a hardcover copy of that. It's very beautiful. But that was done, above board with, asking the original author for permissions of doing that. And the only thing I paid for was the cost of actually printing and getting it sent to Copenhagen. And if someone approaches me and asks me to do that with, parts of my blog, we can probably talk about that as well. So I'm not against that as such, but it's not a project that I'm contemplating at all for myself. If I want to write a new book, but that's going to be a book, thing that I write particularly for that purpose. So I'm sorry that I'm just talking and talking and talking.
Yeah, no, that's completely okay, because I'm also interested in this topic, because I'm also writing something, and my plan is, I know as a person we are every day improving ourselves. And when you turn back 2 years ago and you're looking to your articles, it seems really simple, really non-interesting for you, but it is maybe for you, but for others, it is still a relevant topic. So maybe, this topic, you are not writing book for you, you are writing for your audience, and you can maybe work on your blog posts again. For example, let's say 90% will be okay, but you can add something and you can connect them, like connecting the dots, and create a book. I think this might be a really good idea. Why not? So I would be happy to hear from you that you did it in the future.
Yeah. That's not my plan, but again, if someone else wants to get involved with that, then okay, so we can talk about that. But I have plenty of other things to do. So
that's great that you're planning to work on an interesting stuff. So the other question is about the readers' feedback. What has been the most surprising and insightful feedback you have received from readers of your books? Maybe some erratas or the improvements, I don't know, ideas.
So So not in the books, but just briefly, I already mentioned that as sometimes happens to me with the blog posts, at least, that people will point out that something I wrote was just completely wrong. So that's always very surprising when that happens, and not particularly pleasant. But on the other hand, I do appreciate that. I would rather have that if I'm wrong, that I know about it and I could go in and acknowledge and then publish that and say, okay, that was wrong, because then that also means I learned something. So that's always surprising when that happens. In the context of the books, I think what surprised me the most, and that was really an interesting learning also, was that when I decided that maybe the time was ready to do a second edition of Dependency Injection in .NET, I came to the realization that I wanted a co-author for that. So for people who don't know this, so Dependency Injection in .NET is the first edition, and the book called Dependency Injection Patterns, Practices, or I can't even remember. There's three P's, and I can't even remember the order that they arrive in. But that's essentially, so it's another title, but it's essentially a second edition of the same book. So there's a lot of content that is the same, but there's also a lot of new content in the second edition. So that's a little bit confusing because the title is different. But I decided to I didn't really want to do the work of doing the second edition. So I decided to invite Steven Van Dersen as my co-author, because I had seen a lot of the blog posts he'd been writing and a lot of Stack Overflow's answers that he'd been giving. And I think, okay, so he has this same general approach to dependency injection that I do. So I think he would be a really good fit for that. So he was very happy to help me out with that and become a co-author on the second edition. So that was fine, and I think he did a wonderful job of that. And one of the things that surprised me the most was that he basically wrote a new chapter or a couple of new chapters on aspect-oriented programming. And I've been doing I had some content about aspect-oriented programming in the first edition of the book. I didn't really understand why he wanted to have several chapters on aspect-oriented programming, because I didn't really find that technique very interesting. And then when I read what he'd written, I was really surprised. It took me some time to actually process what was going on, because it turned out that what he called aspect-oriented programming, and I don't think it's a misnomer, but he basically turned it around and he did the same thing that I originally tried to do with the first edition of the book, that he tried to take the idea of aspect-oriented programming and then pull it out of all the technology that you typically associate with that. So just like the first edition of the book tried to say, well, you can do dependency injection without a dependency injection container. Now, what he did now was to say, well, you can do aspect-oriented programming, and you don't need to have an AOP, compile time or compilation step in order to do that. You can use, so basically what he does a lot of decorators, the design pattern, and then he combines that with generics, whatever foo of t, and then he develops a very sophisticated and very clean and also type safe way of doing aspect-oriented programming in just with the building blocks that C# already has on offer at that time. And I had not thought about AOP in that way at all. And it took me some time. And I believe that I may even at the beginning have been a little bit like, what the bloody hell is going on here? What kind of crap is this? And then, slowly over a couple of, and I didn't tell him that. I think I was a little bit, upset at the beginning. And then, it took me a couple of days to sort of get around to it and say, well, this is actually quite brilliant. And I'm pretty sure that I've told him that already, and I really admire that. But anyways, I would definitely want him to see this recording as well, because that really surprised me. And so it was a kind of feedback, because he had been a reader of the first book, and he was very, keen on coming on as a second, as a partner author in the second edition. But he really taught me something, and I thought I'm very grateful for that, because I think that's a very interesting technique and something that I sometimes use. So that was a great lesson.
No, That's really great to hear. Yeah, I also learned about this stuff. So thanks for sharing. Yeah, I guess that's all about my questions. Truth be told, I have more technical questions, but we are out of time. I don't want to take much time because it is about 2 hours we are speaking. Thank you
Yeah,
very much, Mark. It was really, really amazing talk. I will edit and share this on my YouTube channel. I learned a lot of interesting stuff, and some of your ideas completely changed my thinking about the business processes, about the functional programming, and it was really helpful. I hope in the future we can organize the second session to talk
sure.
more and dive into details of functional programming and dependency injection. In this session, we tried to cover everything in a general manner. We didn't dive into details of the specific topics. So I hope in the future we can cover it. So I am planning to have a second session with you,
I'll,
definitely.
I'll be happy to. That sounds like fun too. Yeah.
Yeah. Thank you very much again. It was really interesting. So amazing to have you today. And thanks again, Mark.
Thank you. Thank you for having
Thank
me.
you. Yeah.
Hmm?
Thank you. Have a nice day. Thank you. Thank you. Bye.